Hello student, let's try to understand a problem asked by my student. This is the first order reaction student, but in the gaseous state student. Okay, here pressure is given. This is the type of problem which is asked every year in the board exam student. So you need to be very clear about the concept. Okay, so these questions are very easy, but because of the some tricks student they face the problem. See the question what is there. The following data were obtained during the first order thermal decomposition of N2O5 at constant volume. This is the equation they have given student 2N2O5, 2N2O4 plus O2. Initial pressure when the time 0 is there 0.5, when the time 100 second is there the pressure raised to 0.5.2. This is there. Now this is the total pressure student, total pressure. Now what do you mean by total pressure student? Total pressure. So when you talking about total pressure, that is some P reactant, it is going to be what? TP reactant plus P product. No, P product. This is both are there student in the system, because in the container reactant and product both are there. Now this is the pressure of reactant only. Why? Because when the time is 0 student, no product form, that you keep in mind. What is the formula we use student? So here you see the K rate constant they are asking student. K is equal to first order is there na 2.303 upon T. It will log student. This is P initial. This is going to be P initial. Initial of what student? Reactant. Reactant means N2O5. That you keep in mind. And that is P final student. Final means what? N2O5. Sometime you keep in mind these things. If you are keeping in mind, the problem will be solved easily. Okay, now there is another rule which you use student. If the coefficient is 1, so that time we can use also K is equal to 2.303 upon T. This is log student P initial, otherwise P initial, and then 2P initial minus PT. This formula also we use. Okay. So let us try to understand student. Okay, let us try to understand how can we do. You apply the first formula, that will be much better to solve every problem. You can solve by the first formula, that will not provide any confusion. Let us see. Let us rewrite the question. 2N2O5, it is going to give student N2O4 plus O2. Initially when time 0 is there student, so its pressure is Pi and this is 0, right? That is why I said here it is the pressure of reactant, because here time is 0. And when T is equal to how much student? 100 second. So Pi minus how much? Coefficient 2 is there, so it is going to be 2x. Here is also 2 is there student. In the equation you can see 2N2O4. So it is 2x. Here coefficient 1, so this is going to be x. This is what. Now P total student, PT means P total means sum of pressure of partial pressure of all component. So how can we write the PT is equal to, we can write that is the P N2O4 N2O5 plus P N2O4 plus PO2. So what are there student? So here is, you see these values we have to put. So Pi minus 2x plus this value 2x plus this value x. Now you see in the table this minus 2x plus 2x will be cancelled out. So PT is equal to, this is Pi plus it is going to be x student, right? Now what we required actually, okay, in this question we required this value student. Which one? The x value, where you will find that is, firstly you see the x value. X value if you are calculating from this one, it will be PT minus, it is going to be Pi. PT minus Pi. So let us see the PT, let it be like that. PT Pi value will be 0.5. This is the x. Put the equation 1 student. Okay, this is the value of x, right? Here in the equation, this is the initial pressure and this is going to be final pressure. That is these value required to solve the problem. So let us see. P N2O5, at what temperature you are looking, what time you are looking, 100 second. So what we were writing, Pi minus 2x, this is there, Pi minus 2x, x value you need to plug here. So Pi minus 2, x value it is going to be here. So what will be there, student? Pt minus 0.5, solve it. So here what will be there, student? Pi minus 2 Pt minus into minus plus, this will be 1. Here you see, student, Pi value you know very well. What is the Pi value? Here initial pressure they have given 0.5. So I am writing here, student, 0.5 minus 2 Pt plus what is there, I. So 1.5 minus 2 Pt, right? 1.5 minus 2 Pt. Now here is 1.5 minus 2. What is the Pt? Final pressure they have given, student, Pt 0.512. So I am writing 0.512. If you are putting, so you are getting the pressure at 100 second of N2O5 reactant pressure, right? So here you see the what other things which we can do, student. Let us solve this one. 1.5 minus, if you are multiplying, it is coming 1.024. Now it is again you are subtracting, it is 0.476. Now you can put the value where in the that is k is equal to 2.303 upon t. It is going to be log P initial, what is N2O5, then what is P final, what N2O5. So here is 2.303 upon what is 100. It is the log P initial value. How much is there? 0.5. Where it is given in the table? Here you see 0.5. Final value we just now calculated. What is 0.476? This is there. Now what we can do, student, in this one, you should know the log value, student. Then only you can solve this one. So let us solve this one. 2.303 upon 100, log a by b means what is, student? Log a minus log b. So log 0.5, right, student, minus, it will be, student, if you can do one more things here, if you think that is it can be easy, so you can multiply by 10 and multiply by 10. So it can come, what is there, 0.5 upon 4.76. It gives the more accurate value. So log 5 minus log, what will be 4.76. Now you can solve very easily. So here 2.303 upon 100, log 5 value everybody is know, student, 0.6989, and here is log this one 4.76 value is there. This will be given in the exam, student, 0.6776. This will be there. Now you solve this one. 2.303 upon it is going to be 100, and this is going to be the, if you are solving, 0.213. This is there. Now what is there, student? If you are solving 0.000490, so here you can see k is equal to, it will be 4.90 into 10 power what, minus 4. This is what is the unit first order reaction, student? Second inverse. This is what the answer. It is taking little bit time, but you should understand, student. Thank you.